Thing says that I'm sharing screen. Do you need to switch something at your side?
Yeah, we can see it now.
Yeah, good.
Erik is actually very nice because he's filling in for Patrik, who is unfortunately ill. So he couldn't come, and Erik is taking over some presentation and adapting it a bit, I guess. So take it away, Erik.
Thank you very much. I'm substituting for Patrik, our CMIO, but I work closely with him, so I think I recognize most things. And I would like to recommend looking at this if you want to see Patrik from the HIMED Symposium. And there you will get more of a clinician's perspective. So some of the pictures are the same here in this presentation, but if you want to hear the perspective from a clinician, frustrated with today's data standards, then listen to Patrik in the original. But we'll go through some of the things he said and add with some extra stuff and a current update from Karolinska. So one of the main points Patrik has is that the clinical decisions are based on data, and if we have bad data, then we make bad decisions. So that's why Karolinska is focusing quite a lot on data quality and a data-centric approach. And it looks like we're doing something right, at least. We're not at the very top of the world, but we're among the top players anyway. And we have been working for a long time with data and making decisions based on data, but I think Catalonia has done a similar thing and worked hard with data, and we've both seen that we need something more. We need to go a bit further if we're going to make it even better. So this is a doctor pun, of course. What's atherosclerosis? Well, sclerosis is something about getting less agile. And one of the main problems is that we're very application-centric today. So what we do want the system to do, and what we should do, is look more at the data first and have the applications work on the data as visitors, so to speak. You can read more about these problems afterwards. And how did we end up here then? It's mostly our own fault. The procurements have been very focused on system behavior. So I want a system that can do this and that and that and that. And when you make a procurement, the system that checks the most boxes and has a reasonable price sometimes wins. And which system will check the most boxes? Often it's the oldest system that has had the most time to add functions. And what we probably should be looking for is rather what kind of systems are the most agile that can change along with our needs. So that would be a better way to procure. And the healthcare data is, we need to focus on the data end. So what we can do currently is trying to modify the existing applications, but that is pretty hard. If you've tried with an EHR vendor to, could you please fit it to our little use case here? Or you provide APIs. FHIR is often used here, for example, and other older APIs also. And you can get limited functionality with that works sometimes. Or you buy and build a new application, and then you get data split into even more ones. Well, you've heard what was said from HIMED here recently. Everyone knows these problems. And in the data-driven healthcare, we need data in all steps, and we need it to follow through in the steps. And then so we want the right information to the right people in the right formats, visualized in the right ways, through the right channels, and at the right times. And that's kind of a tricky task when you're involved with complicated healthcare and many actors. So I think openEHR and Karolinska have taken reasonable approach to this, that you start trying to get the data right, to figure out how to register the data in a standardized and a good way. And then you can do overviews, etc. But that requires that you have your data in order. And then once you've gotten this first level done, then you can go to the more deeper knowledge stuff and do clinical decision support and guidelines and this kind of things. But that requires that step one works reasonably well. And then you could also take step 3 with process support and this stuff. But openEHR has been working very hard on this part, and in some later years, this, and recently more of this. So I think it's the right order that matches our needs. So if we look at where we are at now and where we want to go at Karolinska, so now we have a fragmented processes. It's hard to keep up with the changing requirements, and we get some systems are getting to the end of life state and things like that. And then when we want to get data out, which we're pretty good at, we need to do a lot of hard work digging into all these different databases and getting it out in reasonable reports and trying to correlate what comes from this system with what comes from that system. Where we would like to go is more like we can have many applications, because we don't believe that one mega application will suit everybody. So it's okay with many applications that could have different logic, but we want the data in a shared clinical data repository, CDR, based on openEHR. And currently today, we'll dive in a little bit deeper into this picture to understand what the problem is and what you can use different standards for. You can see sometimes you get a PDF from somewhere that someone has to read, etc. And here's a swivel chair. We'll look into that right now. This is an excerpt from how we try to explain this to students at the Karolinska Institute. So you can, if you follow the link, you can see the entire presentation. So what can conversions and reinterpretations solve? That's an important thing to look at. So often you think that we can do some kind of export-import. If this is system A and system B and we want data to get over here, we can do some magic here and some magic there, and we can have a standardized format in the middle. So let's look at the different kinds of differences there are. So differences like this: if you have system A, we have birth weight in grams and a date format there, and system B, this is possible to do. You can tell a technician to write an algorithm that will fix this if we just make sure that does body weight and birth weight actually mean the same thing in these systems. Well, in this case it does, so then we can do the mapping. Then we've got this kind, where we have a surgery note about a hip replacement here in one system. Sorry that some things are in Swedish, but you can look up the SNOMED CT codes if you want them in your own language. And in another system, it looks like this. And here you can look up the ICD codes and other codes. And now I can't see your hands, but if you're an IT person and say, I will take responsibility for doing this conversion in a patient-safe way every time automatically, then you can get very well paid, but you're probably lying. So this is very hard to do automated, and going the other way is impossible because you lack information. So what happens? Well, we have nurses and doctors sitting, looking at this, reinterpreting with the help of their medical knowledge, and then re-entering in the other system here. This costs many hours and a lot of money and pain. And then you've got differences like these. How many cigarettes do you smoke per week? In this system, they selected 6 to 10. What should we pick in this system? Well, it's impossible even for a good doctor or nurse to figure that out. So you see, we've got 3 different kinds of differences, and we've got lots of differences at Karolinska in different systems. And if we get back to this this image here, with this magic usually is useful and can work for type 1 problems. But for type 2 and type 3 problems, you have to solve them, making the internals of the systems, at least the semantics and structure of the system, be the same. And understanding these differences is very hard for even decision makers sometimes. So that's why I think this is a good model, because often you see that the magic doesn't work for type 2 and type 3 problems. So you get monsters there instead. And then you need to do a workaround. For example, in Sweden, we use a lot of fax. You print something out, and then you have the magic happens here instead, in this clinician's head that reads the fax and reinterprets it and puts it into the system. Pretty costly. And you can do it with PDFs instead. We have several such examples at Karolinska also. We do really advanced stuff with clinical genomics, etc. And the result is a PDF that gets scanned into the health record. And then there's the slightly better version is that, okay, maybe we can allow this clinician to actually log into this system and have a look there And then they can, this is what we call swivel chair integration. You sit on your chair looking in one system and then looking over to the other system and typing it in. But still takes time. So this is what the PDF and the swivel chair was about. We want to go away from this and have everything stored in the same place, so you don't need to spend so much time transforming things. And if we look at this, this is sometimes we get questions about openEHR and FHIR. Can't we use FHIR for everything? Well, I would say that FHIR works fine for this kind of problems. If we only had these kinds of problems, then FHIR could work, or any other messaging standard for that matter. But we have loads of these problems, type 2 and 3 differences. And then we need to work with how can we get the content of the systems to be more alike. We'll look closer at some examples here also. So this is another of Patrik's pictures, that you can use openEHR for a little bit more of this cycle, and FHIR is good for these kinds of things, but you can use openEHR also for that. And well, we'll skip this one to save time. We're a bit after time here. So there are some different strategies and patterns to get the data quality in the source systems better. So one way is to use openEHR templates when we configure existing systems. So they're usually configurable. You can make forms and make structures of different kinds. So if we look at an openEHR structure, a template first, then we can make this manual mapping that we turn the problems into type 1 as we looked at before. Or we could embed an openEHR-based form in the present system. They have ways of embedding HTML pages. So we can embed an openEHR form, and then we can write back, keep the, the detailed structured stuff in the CDR, and write back. If they don't have the same detail here, we can do a summary or text or use some of the fields. And then we've got quality data here that we can do research on. And then we could build apps directly on the openEHR platform. But we can't do a big bang switch, or we could, but that's usually has many side effects more than you want. Okay, some current examples. They're partly in Swedish here. So one thing is an experiment that was done is that, as I said, we could configure existing systems being inspired by openEHR templates. So you have the needs of the clinicians, and they have been considered when the archetypes in the openEHR CKM were created. They've been considered when SNOMED CT was created. So you already have a lot of the needs here in models. And then you take the local needs and do the extra local use case specific adjustments in templates. And then you can either annotate a template or make an example form, and you can turn it into Excel sheets if you want that. And then the admins of different electronic health record systems, it could be between different care providers or different systems within a care provider, can use the same structure. And if you're clever, you attach a little openEHR path to the rows in your spreadsheet that you use for as a configuration base. And if you keep that little path and use that in your export function here, then you can easily use the openEHR flat format to get stuff over to an openEHR CDR, even from systems that are not based on openEHR, if you made the templates based on, or the forms based on a template. So this has been tried. It worked with the take care stuff, and we analyzed, and these have similar things. Here's an example of that we're working on right now. This is in Swedish, sadly, but it's if you're at a ward and then you get to surgery and then you get to the intensive care and so on, intensive care and ward again, we have different systems here, and we're introducing a new PDMS system now. So then we think it's very important that this P system, the PDMS, uses similar models as the electronic health record and the surgery system. So then we do, like you saw before, that we try to adjust these to fit each other, even though they're not using openEHR internally necessarily. And if we look even further, you have, when the patient is at home, then you have the portals, etc., for the patient. So there are many places where we can kill or injure the patient just because lack of information transfer in such a thing. So here's the surgery. Here you detect that they have a COVID infection, and you update the allergy stuff, and you put venous catheters and all kinds of things, and then you remove some catheters, add others, etc., etc. So we've injured and killed people by not transferring the information in an efficient way. We want to avoid that. And this is how it looks in systems now. So one system could be like this and another like that. And some things can be transferred, but we need to adjust one or both of them to fit each other so that we can make automated translations. Okay, so another thing that we're working on now is that we have lab systems and we have a current electronic health record system, and we want them over to the CDR. So I won't go deeper into this, but I think you've got someone from Veritech there at the conference that can talk more about this. So that's one way of converting things. A problem in these things is that you get data distortions in each conversion step. So the data we get out here is a little bit distorted. There's a conversion step inside the EHR system also. So what we want to do in step 2 is that we want to connect the CDR directly to the lab system. But we have to start in this end for practical reasons right now. But we're working with, when you talk to the clinicians responsible for the lab systems and show them openEHR, they say, oh, lovely, this would be very nice. Then we could do research on stuff even that are 10 years old, etc., or 10 years into the future. Nowadays, they have a lot of problems with that. So we don't think that the clinicians that care about the lab system mind the openEHR stuff, rather the other way around. They said that this would be lovely to have. So that will be next step. Another thing that we're working on at Karolinska currently with openEHR integration is an app called Alltid Öppet, Always Open in Swedish, and the care portal, which is the staff's portal. And there, as an administrator for this system, you can set up queries like this. And what we've added to that, this was not openEHR based at all. So I'm trying to show ways to use openEHR even in non-openEHR based systems. But then since we own the source code for this, we've asked the company making this or helping us make this to add a way to import openEHR templates. And that is turned into the system's native questions. And then you could just import it, and then you add the conditional logic that they already had in this system. It will behave just like the native queries did. And this is, the queries are then, and then you can do further adjustments, and you can put them in a flow where when you've answered this form, then go to this and then book a time or whatever. These kinds of things are already in the system. And those are not affected by the openEHR stuff we're doing now. And then the citizen and patient have an app, which is used by hundreds of thousands of people in Stockholm. So instead of inventing a new app, we just added openEHR functionality to the current app, or we're working on that right now. It will be running live this fall. And then they answer queries like this. And then you get over to the healthcare staff's view of this, then they can look at the responses from the patient. And we've added, let's see here, we added a button here that says make a note based on openEHR. And that opens up a normal openEHR form based on archetypes and templates, etc. And we've already then saved the response from the patient in the clinical data repository. So it's still in the original system, but there's a copy of it in the openEHR system. And then we can use an AQL query to pull that out. But if you look at this, there's a question, then it's a yes, no, or one of the alternatives. This is very verbose. You probably don't want that in the regular EHR of today. They want shorter notices or structured data. So what we've done then is that we pull the data out from the CDR, populate a form, and then we can do logics in this form and create either shorter notes like this. This says the same thing as these things say. So this could go into a traditional EHR note, and at the same time, the original, the structured answer is still there. And the next step would be to use more like do the electronic health record entry based on structured forms like this, and then you can have them pre-filled again by using the AQL to pull out the patient's responses, but instead we start filling out in the way that the doctor thinks, and we can use normal openEHR forms. This is from Better's system. You can see the examples here. So we've shown where we would like to go. So I think we'll take some questions. I've notified the people in the other meeting that I will be 50 minutes late. So do we have any questions in the chat here? And while you're writing.
We'll look at yeah, there it is. I'll look in the room as well. There's some questions in the room. No questions in the room.
Okay, then I can explain a little bit about this when you're thinking at least about one question then. But so we've got what you saw was the Altidep and the word put on the patient and the staff's thing, and you can use openEHR in different ways. So this is a non-openEHR system, and here we opened an openEHR based form inside that system, and we can do the same in the current non-openEHR based system, and we can read and write from the CDR. And then you've got the native storage, and you've got some admin data, you've got some patient-reported data. In the CDR, we will have some patient-reported data, which is not under the same laws in Sweden as the electronic health record per se. So, but we can have both in the CDR, we just tag them in different ways. And then, of course, the CDR won't be everything in our system. We will have many other kinds of storages also. But for the structured data, we prefer this if possible, because then we get a very decent normalization of data into a very decent format when we take it from different systems without having to invent too much ourselves.
I think there's a lot to think about and to take in. A lot of inspirational ideas here. But Erik, thank you. I don't see any new questions, so thank you for your presentation.
Bye-bye.
With that, we have a 15-minute break. 15, yeah. Yeah, we don't make a. Thanks, Erik. I'm going to talk to.
Bye-bye.
Stretch and carry.